Hello everyone and welcome back to the GoFr channel. I am Divya Darshana and today we are diving into yet another crucial topic, that is configuration management in GoFr. Ever thought about how we manage configurations across different environments? In modern development, you might set different configurations for each environment like local, staging, and production. For example, you might have different database credentials, API keys, or feature flags for each environment. And while this seems simple at first, it can lead to issues because traditionally mixing up these configurations or manually setting them for each environment often cause problems, whether it's missing environment variables, hard-coded credentials, or inconsistent settings. And that's exactly where configuration management comes in. Without it, small errors can break your app where it matters most, especially when deploying to production. Now, we all know how important it is to have a smooth, reliable way to handle these configurations. So, how do we make this process effortless and foolproof? Well, that's what we are here to talk about today. GoFr simplifies configuration management, making it reliable, easy to use, and perfectly aligned with modern development practices. We'll also see a quick demo of how GoFr can help you connect to a database using the same configuration management approach. So let's get coding with GoFr. We simplify configurations by following the 12-factor app methodology, which separates configurations from the application code. And all you need to set that up is just a configs directory in your project's root of your application. So going back to our HTTP server project that we had set up in the previous video, we now create a configs directory which will follow the following structure to define the configurations for different environments in our application. Here, each file corresponds to a specific environment and GoFr uses app_env variable to determine which file to load. For example, for development, we just run app_env set to dev, go run main.go. Similarly, for production, we can set app_env as prod. If specified file isn't found, GoFr gracefully defaults to .env or .local.env. Please note that we follow a clear loading sequence, that is first loading the .env file, then overriding it with the .local.env file automatically or with the respective env file when app_env variable is set to dev, stage or prod. Finally, system environment variables are loaded to ensure all configurations are consistent and up to date. It's time to see GoFr's configuration management in action. If we do not set up any configs for our HTTP server, by default it starts at a port 8000. But as we have specified in our .env file that the HTTP port should be 8081, now that we run go run main.go in the terminal and our server starts, we can see that the HTTP server starts at the port 8081 itself. GoFr manages a lot more configurations through its env files across environments. As I go further introducing various other features of GoFr, in the future videos, we will be using our env files a lot to set up the configurations for those features. In the scope of this video, we will just explore connecting to the database and executing DB calls. So now that we are back to coding, let's be honest, writing endless boilerplate code just to connect to a database can be pretty tiring, right? But what if I told you there's a way to connect to MySQL, PostgreSQL, or even Redis in seconds effortlessly? In this demo, we'll show you how to connect to your SQL databases with zero hassle, and I'll even walk you through some example DB calls in action. But before we dive in, make sure you have Docker installed and running on your system. You should also have an SQL container with its instances up and running, along with the necessary configurations to connect to the database. Additionally, ensure your table is already created within the Docker container. In this setup, we assume you already have a running Docker instance with an existing database called test_db and a users table populated with some entries. If you encounter any issues during setup, please refer to the articles provided in the description below for guidance. Now in the .env file, we set the following database configurations To connect to the Docker instance of MySQL that is already running, we specify the host, port, username, password, and the database that we are connecting to. The DB dialect determines whether we are using MySQL, Postgres, or SQLite. In this use case, as we are using MySQL, it has been set to MySQL. We can also set the maximum number of open and idle connections for any of the MySQL, PostgreSQL, SQLite databases by adding the following configs in the .env file. So now in a main.go file, let's create a new handler. Let's name it SQL handler, and this will be executed when we hit the /SQL endpoint. So we create the SQL handler, and if we closely explore the context that every GoFr handler has, we can notice that this context CTX has all the DB and their methods that we might want to access in our handlers to make the DB calls. So as here we are using SQL, we can go ahead and call ctx.sql.queryRow and then give the query, that is select name from users where id is equal to, and give the id, and then the result that we get, we can use .scan method, and let's create a variable named as name, which is of string type, and then we give the reference of this variable in the scan function, and then we check for the error, that if error is not equal to nil, then we return nil and error, and if it is equal to nil, then we return the response, that is hello, and the name that we have fetched from the database, and nil for the error. Now we are ready to run our server again. Notice that we have not written any logic to connect to SQL in our code. So we go ahead and run main.go, and we can see in the logs that we are connected to SQL based on our configs. Now we can go ahead and open a browser and actually hit the /SQL endpoint. Hitting the /SQL endpoint, we can see that we get a response, hello John, where John has actually been fetched from the DB itself. Just like SQL, you can easily connect to Redis by adding its details in the .env file. The process is just as seamless. And here's the best part, GoFr doesn't limit you to MySQL or Redis. We have externalized support for other databases also, like MongoDB, Cassandra, ClickHouse, and more. This keeps your build size compact, including only the code for the data sources that you use. Curious about how we achieve this lightweight modular approach? Well, stay tuned for our next video where we'll dive deeper into externalized data sources and dependency injection patterns in GoFr. In the meantime, check out our open source code at github.com/gopher.dev and explore our documentation at gopher.dev for more examples on working with SQL, Redis, and beyond. If you found this video helpful, don't forget to like, subscribe, and share it with your peers. Drop a comment below with your thoughts, and I'll see you in the next one. Until then, happy coding with GoFr.